Welcome to Math Minders Academy.
So today we want to consider modular arithmetic. Modular arithmetic. Now, what does it mean? It means a system whereby we are concentrating on remainders when a particular number is used to divide other numbers. The number used is called the modulus or the mode. The remainders are actually called the class of residue or the residue classes. We are interested in these residue classes because they help to solve a whole lot of practical problems, as we are going to see in this tutorial class. Now, let's look at a particular interesting we have, let's say we are given this circle and we decide to partition this circle into 5. And then let's call this 0, 0, 1, 2, 3, 4. Now, these numbers, they are, because this circle is partitioned into 5, this is going to be our mode 5 system. This is going to be our mode 5 system. So 5 is the modulus. Now, what it means is that by the time we go around this circle 5 times, we arrived at a number 0. And we begin the journey again. After we have taken 5 steps, look at this. If we start the journey from here, we'll move. We are going this way. We move 1, 2, 3, 4. The 5th step will return us to our original position. We move again. Now, any counting that follows this pattern, is actually adhering to the rules of modular arithmetic. We can handle some arithmetic operations here. For example, look at, I want to find out what happens if I'm standing at the position of 3 and I take 4 steps away. Where will I land? Where will this movement take me to? This is where I am presently, and I'm taking 4 steps. 1, 2, 3, 4. My value is going to be 2. Remember, this is mode 5, because we partition this into 5, partitions. So this happens even in real life, where we have the clock partitioned into 12 parts, and then we have 1 to 12. And each time we get to 12, we return back again, and the clock hand will start moving from 1 again, gets to 12, it starts moving. That system is actually counting in modulo 12. So it's actually mode 12. What it means is that 3 plus 4, 3 plus 4 minus 2 can produce a number that 5 can perfectly divide, and which is true, because if you look at this, what we get here now is 5, and 5 can actually divide 5. So now let's take some examples. We may be asked, what is what is 25 in mode 7? What is 25 in mode 7? Of course, there are different ways. I can say let 25 be x in mode 7. So what this implies is that 25 minus x, 7 must divide whatever s is. 7 should be able to divide. If I subtract s from 25, 7 should be able to divide it. Now let us look at the possible values. Of course, if I subtract 4 from 25, I'm going to get 21. And of course, if I divide 21 by 7, I'll get a remainder that is a whole number. Now, can you think of another possible value of x? But remember that any value of s that we are taking must be, the condition is that it must be less than 7. Is there any other value of s less than 7 that we can subtract from 25 such that when that subtraction is performed, whatever that we have remaining, 7 can perfectly divide it? No other number. Of course, the next number that we can get here is 11. 25 minus 11 is 14, but 11 itself is bigger than 7. Our value, the value that we get after we have performed the operation, must be smaller than the modulus. Must be smaller than the modulus. We cannot get a value bigger than the modulus. So our answer here is 4. But now there's another easiest way of doing this. What's that easiest way of doing this? Let's look at that. Now, I can handle this another way. What is 25 in mode 7? That means I can say if I use 7 to divide 25, it's going to give me 3, remainder 4. This remainder here is what I'm interested in. This remainder here is what I'm interested in. That means 25 is 4 in modulo 7. Now, let's look at another one. Let's look at another example. What if we are asked to find what minus 32 will be in mode 9? What will minus 32 be in mode 9? Now, let's look at our solution here. Now, look at minus 32. 9 cannot divide it fully. But there is a number that 9 can divide, and the remainder will be 0. If I add that number here, it will be the same as adding 0 to minus 32. Can you think of that number? It's a positive number so that if I add it here, I'm going to get a positive quantity, and that number itself in mode 9 is 0, because if I use 9 to divide that number, I'm going to get a remainder of 0. That number is 36. That number is 36. Of course, if there's no other number smaller than 36 that I can add to minus 32 to give me a positive number. Think of any other number that 9 can divide. If you take 27, yes, 9 can divide 27, and our remainder is 0. But if you add 27 to minus 32, you will still be left with negative. Our set of remainders must be whole numbers. The residue class is actually the set of whole numbers. So we will be interested in remainders that are, of course, a remainder will definitely be a whole number. It's going to be a positive number. So now, this is like adding 0 to minus 32, because 36 in mode 9 is 0. If I use 9 to divide 36, the remainder is 0. So now I put mode 9 here. Coming down here, now let me add these two together. That gives me 4. And in as much as 4 is positive and is smaller than 9, we don't need to proceed further. So our answer is 4 mode 9. Now, this is one way of getting this answer. There's still another way. What of if someone is unable to think and guess 36 right? Can there still be another way? Yes, there can still be another way. Let's look at a second method. Here, we are presented with minus 32. We are presented with minus 32. That is, I want to combine two numbers that their value will give me minus 32, but one of these two numbers, will be 0 when I use 9 to divide it. Look at this. I can have minus 36 plus 4 here. I can, because 9 cannot fully go in minus 32, but there is another negative number that 9 can fully divide, and that is minus 36. If I take minus 36 and I want to add something to minus 36 so that my value will still be minus 32, the number I need to add is 4. So it now means, therefore, that minus 36 plus 4 in mode 9 is the same thing as minus 32 in mode 9. Now, look at this minus 36, 9 can divide it fully and our remainder is 0. So this is like saying 0 plus 4 mode 9. And 0 plus 4 is 4 mode 9. All right. Now, we have seen addition. Let's proceed to multiplication now. Now, what if we are asked to evaluate 5 times 8 in mode 7? Now, Remember that this 5 times 8 is 40, but there's also another way. This can give me 5. Look at this 8, it's bigger than 7, so we can reduce it because in mode 7, you are meant to see 0 to 6. 8 is not a number in mode 7. So we can actually return this 8 back to a mode 7 number. What we do is we divide this 8 by 7 and drop our remainder. So if you divide 8 by 7, the remainder is 1. So now we can say 5 times 1, it gives us 5. Mode 7. So that is taken. Now let's look at another one, another example. Let's say this is 1. Let's look at the second one here. If we are asked to find, this is division, 14 divided by 3 in modulo 9. In mode 9. So look at this 14 is bigger than 9. So reduce it to a mode 9 number. So we divide 14 by 9 and drop our remainder. So our remainder is going to be 5. So we have 5 divided by 3 in mode 9. Now, if you look at this, of course, both 5 and 3 are mode 9 numbers, and 5 cannot actually divide 3 to have an integer, that will belong to mode 9 system. So we say here that there is no solution, or that this is not possible. So we now say, here, not possible, because we've reduced these two values to numbers in mode 9. And we have seen that this division cannot actually work. So it's not possible to perform this operation that combines 14 and 3. Of course, some other numbers can work out well, even with the operation division. But between 14 and 3, there won't be any solution. Now let's look at number 3, another division that will work. Let's say 7 divided by 2 in mode 5. Of course, so 7 is not a mode 5 number because it's bigger than 5. All mode 5 numbers are meant to be 0 to 4. So let's convert. 7 divided by 5, what would be the remainder? To give us one remainder, 2. So we have 2 divided by 2 in mode 5. Here, our answer is 1 in mode 5. So we got a value that is valid here. All right. So let's proceed now to see how to solve equations in modular arithmetic. Supposing we are asked to solve the following equations in mode 7. How do we handle this? Let's see our solution. Now, the first one is 2x equals 1 in mode 7. So we are looking for the value of x here. Now, I'm going to have 2x equals 1 plus 7. Why am I using 7? Because I know that adding 7 to 1 is the same thing as adding 0, because 7 is 0 in modulo 7. 7 has the value 0 in modulo 7. So this becomes 2x equals 8 mod 7. So when you divide both sides, s is going to be 4 in mod 7. So that is clear enough. Let's look at the B question. We have 2x plus 6 equals 1 in mode 7. Now, how do we handle that? Here, we are going to have 2s equals 1 minus 6 mod 7. 2s equals minus 5 mod 7. So we now need to do something here. I can say 2s equals minus 5 plus 7 in mod 7, because again, I know that adding 7 is like adding 0 to minus 5. So 2s equals 2 in mod 7. So dividing by 2, you have s equals 1 in mod 7. All right. So with this, we now proceed to the next one. So here we have small exercise as classwork, just to look at how far we have gone in understanding modular arithmetic. So what you do now is to quickly pause the video at this moment, go through these 5 questions, solve them on your own, and then you proceed to the next part of this video to see solution to these 5 problems. Now let's see solution to this problem. So the first one, number 1, we have 9 plus 16 mod 7. So in mod 7, 9 is going to become 2, because that's the remainder you get when you divide 9 by 7. And 16, when you divide 16 by 7, you are also going to have a remainder of 2. I mean, when you divide, so you now add these values together. 2 plus 2 gives us 4 plus 7. So we move on to the next, number 2. We have minus 6 minus 8 mod 3. Now, of course, if you look at 3 can fully go in minus 6 to give us, the remainder will be 0 here. Then 8 in mod 3 is actually going to give us 2, because if we divide 8 by 3, we have a remainder of 2. Now, if you look at 0 minus 2, this gives us minus 2 mod 3. Of course, we are not going to stop here because our value is meant to be positive. So I know that if I add 3 here, it's the same thing as adding 0 mod 3. Of course, minus 2 plus 3 is 1. So finally, I have 1 mod 3. All right. Hope you are taking note of this correction. Let's look at number 3. Number 3, we have 15 times 18 mod 7. Now, before we proceed to see the solution to this question number 3, if you're enjoying this tutorial and you have not subscribed, please subscribe, click on the share button so that you can share this video, others can have it. Then click on the notification bell so that each time we publish a new video, you have access to it. And then go to the comment section and tell us how you feel about this video. Your feedback will help us to make necessary improvement. So let's continue. Now, 15 divided by 7, the remainder is 1. And when we divide 18 by 7, the remainder is 4. So 1 times 4 is 4 mod 7. Then number 4. We have 5x plus 2 equals 4 in mod 7, and we are asked to find the value of x. So we can write that 5x, equals 4 minus 2 mod 7, 5s equals 2 in mod 7. So from here, we are going to have 5s equals 2 plus, let's add 28. 7 can go in 28. So 28 is also 0 module 7. Of course, we look at multiples of 7 that can make us, if we add it to 2, we get a number that is divisible by 5. Ensure that the multiple of course, all multiples of 7 will be 0 in modulo 7. So we just can play with them in order for us to get something that 5 can fully divide. So we have 5x equals 30 here in mod 7, and of course x is actually going to be 6 in mod 7. So this is how far we can go in today's video. This is part 1 of modular arithmetic. We are going to proceed in our next class with part 2 to wrap up the modular arithmetic. There we are going to look at multiplication table, addition table, and all of that. And we are going to look at how to define sum operations and then use them to build table and then proceed to answer some likely examination questions. Why not check our channel from time to time so that you get this release, and for you to be able to be abreast of the development, click on the notification bell so that once we drop that video, you'll be able to get it, and then subscribe if you have not done so. Thank you very much. Thank you for being here with us up to this time. See you in our next class. This is Math Minders Academy. Bye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasies